Graphs of functions. In this video lecture, our objective, we want to identify the graph of a function. Okay, what do we know? Well, we know what a function is, so let's go over that again because that's going to be key to identifying whether or not it is the graph of a function. A function is a relation that associates each element of the domain, each input, each x value, with exactly one element of the range, the output or the y value. The key to this when it comes to the graph is that each x value can have only one y value, okay? Each x value can have only one y value. What that leads us to is how do we determine whether or not it's the graph of a function? And we use what's called the vertical line test. Okay? The vertical line test lets us know whether or not it's a function. A graph is a graph of a function if and only if every vertical line intersects the graph at most one point. Again, because each x value can have only one y value. So we can do a vertical line test. Let's take a look at that with four different examples. Example 1 here. This is the graph of y equals x squared. I drew my xy coordinate, and here's the graph, y equals x squared. As you probably remember, it forms a parabola. Mine's not perfect, but it should be symmetrical. It should be exactly symmetrical about the y-axis. Okay? Does every x value have exactly one y value? Yes. If I pick this x value, that's the y value. If I pick this x value, that's the y value. If I pick this x value, that's the only y value. If I pick the origin, the only y value when x is 0 is 0. Okay, and as you'll notice, any vertical line I draw only intersects this graph one time. So this is the graph of a function. Okay, let's take a look at our second example here, letter B. Let's take a look at the graph of y equals x cubed. The graph of y equals x cubed comes from down below. It works its way up, does kind of a curve to the right, crosses through the origin, and then it kind of mimics the y equals x squared graph as it grows, as it goes further, as the x values get larger. Okay, so again, does every x value have one y value? Well, for this x value, I only have one y value. For this x value, I only have one y value, okay? And again, if I were to draw vertical lines, the vertical lines only touch the graph in one place, okay? At most one place. So this is a second example of a graph that is the graph of a function. Okay, I needed more space, so I turn my paper over. And we'll look at these last two examples. As you might imagine, they're not going to be graphs of a function because I showed you two that were. Here's the relation x equals y squared. Okay, and this is how it graphs. It graphs like this. It's a parabola that opens to the right. Okay, is this relation a function? Well, for the origin, if x is 0, y is 0. And if you look at the y-axis as a line, that one touches the graph at only one place. But every other vertical line I draw touches the graph at two places. Okay, which means is for this x value, I have the option, I have two possible y values. This y value and this y value. Okay, and as a function for each x value can have only one y value. It must be predictable. If I say this x, let's say this x for example is 4, Well, 4 can equal positive 2 squared or negative 2 squared. It's not predictable. It's not one thing. It's a possibility of two things. Okay, so this is not a function. It fails the vertical line test. There are an infinite number of x values that have more than one y value. Our last example, letter D, is the graph of a circle. And we've seen this equation of circles, x squared plus y squared equals 1 is the standard form of the equation of a circle. And here's the graph. Pardon my freehand, it's a little bit, looks like it's a little bit kind of flattened over here, but we want to pretend that's a good circle. And again, I labeled the graph here. Okay, so is it a function? Does every x value have one and only one y value, have exactly one y value? Well, no. This x value, if I select this x value right here, I don't know, let's say it's 3/4. This x value has two y values. It corresponds to this y value, and it corresponds to this y value. And as you can see, everything that is between, this is actually 1 and -1, everything between 1 and -1, all these vertical lines represent x values that have more than one y value. All these vertical lines touch our graph, touch our circle in two places. Okay, so again, this one is an example that is not a function. Okay, so the key, again, the definition of a function, every x value can only have one y value, and the vertical line test can prove that to you.